All right, welcome guys. So this is going to be a talk called Whirlwind Tour of the Scala Ecosystem, which it turns out there was no little blurb about what this is. So this talk is going to be stepping through a bunch of libraries in the ecosystem quickly. We're going to do a lot of breadth, a little bit of depth, and it's going to encourage you for where to look later for things you might be interested in. And I'm trying to introduce you to some of the things in the Scala community that were true when I joined. For example, instead of using something that helps you write slides, you should write a framework to present your slides. So we actually have done that. This is our slide framework, so welcome to the community. All right, who am I? Well, this is who I am. This guy right here. Hi. Maybe it looks better this way, I don't know. I'm the author of Scala In Depth and SBT in Action. I've been in the community for a while, a really big Scala fan, and I really think that you can build lots of cool stuff in Scala, even if it's generally useless. I'm not really sure if ANSI Skype is going to be a thing, but just putting the idea out there. Right. So what we're going to do here is we're going to cover kind of the core Scala libraries that are actually part of the core, things that you can make use of, what they're good for, in case you haven't heard of them. Then we're going to talk about the early wave in the Scala community, kind of where we came from, but things that are now staples, that are just generally solid libraries. And then we're going to cover a little bit about up and coming things. So where the ecosystem's going, cool things to pay attention to. So in the core Scala libraries, there's really the standard library, and then a couple modules, and there's more and more modules showing up. And you'll notice that I haven't actually listed a few of the Scala modules because I think those projects, the need for them is actually sort of dying in the ecosystem. The one that I don't list here is Scala Swing. And I actually kind of feel like Swing in Java is just not really a priority in anyone's mind really anymore. How many of you guys write desktop apps in Java? Okay, cool. Hope no one minds that we cut it from the list. All right. First, let's just cover the Scala Collections library. So for those of you new to Scala, the Collections library lets you do really nice things. This is the most used library in any code base I've ever written. This is some example code that just says, for all the people in this list, look at the address, or all the addresses of where this person lived. Take the city. If the city is San Francisco, yield this city. It actually should be yielding the person. Sorry, there's a bug. Anyway, so this is a way of looking at your collections and manipulate them, return something with expressions. It's a really rich library. So the collections library has a set of, 100-some methods that you can make use of. Highly recommend you get into this and learn it. And like I said, we're going to go through a lot of libraries, so I'm not going to spend a ton of time on the standard one. If you have questions, you can save them for the end. Option and try are two things in the standard library that let you do what basically help you get rid of null and help you denote that you're passing a failure. So option should always be used in Scala instead of null to denote whether or not something exists or doesn't exist. Okay? A lot of times in Java you return null to say that something doesn't exist. In Scala we have this library class called option. You can have methods return option, you can join options. Here's an example of find user or else user.anonymous as a means of handling the non-existence of something, right? That's what this is all about. Try is another thing that's just a handy way to catch exceptions and lift them and pass them around. So these two things are kind of nice, but things you should be aware of in the standard library. If you're not using them, they're useful. Another big thing in Scala is this futures library. This is actually really powerful right out of the box. What futures do is it kind of gives you the means to do base level asynchronous programming in a non-blocking fashion that turns out to be pretty efficient. So in this example, we have a method called handle web request. We denote that it's asynchronous by saying it returns a future. And we take two asynchronous method calls. Get user data is going to go ping a database and eventually return user data. Get query data is going to go ping a database and eventually get query data from my web request. I zip these two futures together. I get a new future that has the user and the data in it. But I can use a nice for expression to rip those both out, do a quick filter, whether or not the user's authenticated, and then render the results out the data stream. Right? So futures are super, 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 super elegant for very base level asynchronous programming. You can do a lot with just these things. The Play web framework essentially says, hey, these things are that nice, this is our core API, right? This is how you handle every web request in Play, is you get in something, you return a future of something. And the blocking nature of Play, if you use a blocking request, they actually convert it into a future. All right, the next thing we're going to cover is actually Scala has a process library. You can import sys.process, and then you can use all sorts of fun operators like bang bang, or bang bang bang. Right? This is, again, I'm introducing you to Scala. We have fun operators. What bang bang does here, or I guess exclamation, exclamation, which is not as fun to say, this will run the process and take all of the standard output returned from the process and return it as a string. All right. Not only that, if you use just single bang that returns the return value of the process, you can optionally feed the standard in and standard out somewhere. And there's a lot more rich controls. You'll see some utilities and things use this library to just quickly fork things and run if you're doing little scripts. It's pretty handy. And it's based on SPT's process library, which is why we have the awesome operators. All right. Next up actually is Scala XML. This is a feature of Scala that is somewhat contentious. Some people like it, some people don't. Martin said he's going to remove it, but I still think it's highly valuable to just be able to write XML quickly, right in the language, as sort of a first-class citizen. This is similar, you know, in other languages you might have an external DSL, like a whole secondary language, where you have like a .jsp, where you would render your XML into. Sometimes it's handy just to dump an XML doc. Why is it handy to dump an XML doc? Because there's legacy tools you're interacting with that only take XML or HTML or something, and you can literally embed Scala and XML together. It's pretty nice. One last library which I think is really, really nice, and I think tends to not get introduced as much anymore, is Parser combinators. So we're going to take a little more time in here. Parser combinators, the idea is I have some sort of file that I'm reading that has some type of string format, and I want to turn it into things that I understand in a computer. So what I do is I start with a parser for a small bit, and I combine it with another parser for a small bit, and eventually I get a parser for a very complex thing. Okay? So here we have a parser for a word, which says a word is any lowercase a to z. We do not like international letters here, okay? Sorry. In this parser, mostly because I want it to fit on the slide. But we don't like anything uppercase to make our word, right? We'll parse any of that, and the default parser here will give us each individual character in an array. So I say, after you parse each individual a to z string that's together, contiguous, we're going to take that result and we're going to string it to turn it back into a string, and we get a parser of strings. So the underlying parser architecture was character by character, but we've mapped it already, taking a primitive parser, which is this regex thing, and turned it into a parser of strings. I can get word by word, okay? So every a to z will parse as a string. Then we do one for numbers. Numbers are either 0 or 1 through 9, or a digit, any number of these things, right? So we parse these, and then we call underscore toInt on it. All right? That's yet another method that's defined on string. So now we're parsing things that look like integers or strings that look like integers into actual integers. All right? Now, finally, parser of word frequency says, I want you to parse the word part, I want you to parse the number part, and then when you're done, I want to extract the string and the integer. I'm going to create a case class that has the string and the integer in it. All right? When you're done with all of this now, I have a parser that will look for things that is text and then a number. And I get it back as text and a number. All right? So this framework, I'm saying all right too much, sorry. This framework is really, really gorgeous for when you have something custom that you need to parse. Or, what I've used it for a lot is in your log files, which are just text. You need to do something useful with these. You can use you can grab in your log files, parse through them with a very, very simple yet concrete thing that grabs the bit you need and look for the data you need. That's actually becoming less and less something you need at work because of better and better logging APIs, better and better logging tools, but parsing string and text is still a very useful thing. Anyway, so that's the standard library. The most important, like I said, the most important, most overlooked is this parser combinator bit. Next, we're going to talk a little bit about the early ecosystem of libraries, okay? So these are the libraries which were kind of like pushed Scala. All right? The libraries that have made Scala successful, the things you should really be aware of. First is Akka. Akka is an actor framework. All right? So the reason you care about actors is you can construct something that is a little bit like an object and you can actually send a message to it. The beauty here is since everything is sending a message, you have a little bit of location transparency of, you know, it's not directly encoded that this thing talks to this thing, and you can start scaling these guys a lot better than you would just regular OO code. So actors are a very, very nice way to do really concurrent, really efficient programming, but there is a little bit more head twisting and disconnect that you need to do to start with Akka. It's a very nice library. Highly recommend that you guys look into this. Next is actually something called Dispatch. Dispatch actually made a lot of utilities in Scala easier. What Dispatch is, you point at a URL and you download it. That's it. Point at a URL, download it, convert it into a format. This example, we import Dispatch, we have a particular URL, we say we want to connect to it via HTTP, we want to say if the result is okay, turn it into a string. Okay? You can also do this where you turn it into JSON and parse it. Dispatch actually forms the core of the community for a lot of the REST APIs that people use. So if you're going to talk to GitHub, you can literally throw together a Dispatch REST API in a few minutes. So this kind of pushed a lot of these neat little tools that people started using. The next thing to take a look at is Spire. Spire is a mathematical processing library. All right, so here's an example of a complex. This is a complex double where you have two doubles on each side. One thing that's really interesting about Spire is it really focuses on correct math. They actually had an implementation of complex where you can have two floats, but the way it encodes at runtime is it stores in a single long, so that memory-wise you're taking less data entry points than if you actually had an object with two floats, because it's just a long at runtime, yet you can treat the thing as a complex and do very efficient and quick math operations, right? This is where you find things like quaternions if you're doing any sort of rotational geometry. It has fixed point numbers if you want to actually make sure that the decimal point is handled correctly. There's a lot of type classes. If you're not familiar with what type classes are, they're kind of Scala's version of a better interface. But you have a type class for like trigonometry, for the notion of a ring, and all of the underlying things that are in Spire. Okay, we're good. All the underlying things in Spire, you can actually make use of these type classes. to write a very simple representation and implement a lot of rich operators and combinators. For those of you who aren't familiar with what a ring is, or a semi-group, or a trig, you don't really need to know it to use the library, but if you're implementing a new numeric type, it's beautiful. You can actually prove that mathematically this thing follows some laws. The really neat thing about Spire is it's super efficient. These guys have really eked out as much efficiency as they can. So, all right. Moving on, we have Slick. If you're interested in talking to a database, Slick is a very good way to go. Okay? Slick's goal is to make talking to a database feel like native Scala. And there's various levels of the API, but I'm showing you the most Scala API. This should look like you're talking to a collection. Right? There's a way that you define a thing, coffees, which is actually a table in the database, and then you write collection-looking code, and this turns back into SQL. You can also, in Slick, write SQL and then map it back into Scala case classes. So you can still write raw queries. The idea is to give you the best of both worlds, right? Before, in like the Java world, there's the JPA spec, where you always start with Java and then turn this into SQL. But that process might be a little hidden, and if you ever need to high tune a query, you can't do it. With Slick, you have both of these layers at the same time. So if you want the automatic mapping to SQL, you have it. If you want to go directly and write a query, you can also do that. So if you're talking to data, yes?
Is there a round tripping from like the catalog definition to these Slick definitions?
Okay, so the question is there catalog round tripping of the definition to the Slick definition? The answer is yeah, there's actually, it's a separate build step where you can take something and generate the classes. And that's, I think that's in Slick 2 was when that came in. So yeah, the question is there decent tooling or is it all command line? It's an SBT plugin, if that helps. I don't know if there's a plugin for other build tools yet or not. So, all right. Next up is Scala Z. Scala Z was the contingent of the Scala community that really wanted to push purity, side effects, forcing laws, that sort of thing. This is an example of some Scala Z code where we actually take, you're taking these collection-ish things and kind of treating them very abstractly. So for example, I mentioned option, right? An option is a collection of 0, 1 value. So if I have 3 of these things, 1, 2, and 3, and I want to sum the values together, I don't have to write code to extract it from each value, check if it existed, add them together and create a new option. I can use what's known as the, well, this actually has 5 different titles, but it's the Cinnabon operator, it's the Scream operator, lots of different names for this guy, but it's actually applicative functors is the underlying principle. You can take these things, you can take a function that operates on 3 values and get a result that's still nested inside of the option. If one of those values happened to be a none, meaning there was non-existence, the right-hand side would turn into none. So these types of high-level operators to do really rich functional transformations come in Scala Z. And they actually have a lot of rich collections in here. Here's another example where I have a list of options, and I want to turn this into an optional list, where if anything underlying is none, I want to get a none back. But if all of them have a value, I want the thing as a list. So you invert from a list of option of integer to an optional list of integer, right? These are kind of high-level things that you eventually start to reach for, like, man, I wish this function existed. Well, it does, it's in Scala Z. They also have a set of functional collections, things that are handy that have certain proofs, like non-empty lists, that kind of junk. It's definitely worth looking at, but we'll talk a little bit more. This library actually has a fork from the guys who brought you Spire, and I'll talk a little bit more about that later and why I'm excited by that. We're going to show you Lift. Lift was the first web framework that was popular in Scala. I actually programmed in Lift a while ago, and it brought a lot of us in. Lift is like a GWT. It focuses on server-side rendering and security. What you start with in Lift is you actually start at the top with a little XHTML fragment that says, here's what renders for this thing. And then from there, you look up the code components that you need to render. All right? So here we're saying first, surround this HTML I have with this template. But you start here and then look for the template as opposed to it automatically going the other way. Then you say, I'm going to put a div, and I want you to grab the template class and its show method, and whatever it tells you to render, put it here. Okay? In template, you see there's this dispatch method that takes a show, command and returns the show method, which is a XML translation. And a lot of this code got cut off because it's kind of long, but you're doing essentially CSS selection transformations, okay? So in head 1, you put name, in head 2, you put email. If you don't have any records, you just render a text of no records found. It's a very interesting framework. If you're into like server-side rendering and trying to do component things on the server side, it's still definitely viable. The thing that I think has happened is a lot of the web has moved towards not this model at all. So the servers are literally becoming just simple REST servers, and the JavaScript clients are becoming more and more rich. Very, very rich. So generally you're serving a simple static page and then a super rich JavaScript client talking back to REST, which is what Play framework does. So Play, there's a routes file where you say if someone hits this URL, here is the object and method which is going to handle it. So package controllers has a action which it will perform. If you look at this this method, it's pretty raw, right? It's literally just an object. It has a method called index. That index is a play action, which is a particular type. This action is actually generally asynchronous. This code is going to get lifted and turned into an async future call. But what this does is the OK method will call the index method of a particular view. What's the index method? Well, it turns out the HTML templates you write in Play turn into functions on the JVM that you can call as functions. So here is my view at the bottom where this is the arguments to the function. So it takes an implicit request header. And then the @main is actually the function of the template, which will render around me. And I pass into it some more HTML to render, right? So you'll notice a little bit of similarity, but completely inverted in how they view the world, all right? Anyway, we happen to use Play Framework for our services right now, so I'm a little biased, just to give you an FYI. All right, let's look at Spray. Spray is now called Akka HTTP, but I'm covering the early ecosystem where it was Spray. Spray is, if you take that actors library, where everything is sending a message, this was a mechanism to serve HTTP and REST APIs directly within the actor system. Okay? So here what you see is they created a DSL for routing, which is embedded in the Scala, and then you create an actor which can respond to route calls, all right? These can do all the nice actor things of sending messages, having responses come in asynchronously. If you're using Akka hardcore and you don't need any of the other things, Spray is a great way, or Akka HTTP, to make sure that you can service REST requests and it feels more natural to the Akka ecosystem and the Akka application. Next up is a thing called Unfiltered. If you're not using Akka, then this is actually another nice way to just, in Scala, write something which can pattern match on some HTTP request and return a result. If you need to do a real quick, admin API for a server, this is another great way to do that. It actually uses, you can choose how it's hosted. This example uses Jetty, but it's super simple, super elegant. Something to take a look at. All right, and now we're getting into testing libraries. This is actually, I would say, the primary reason to use Scala. Testing. So the Scala check is awesome, 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 awesome. You shouldn't use it everywhere, but the basic idea is we're going to let the types lead us for how to test. All right, here I say for every string you can invent, run this block of code and make sure it returns true. This is beautiful if you're writing a parser. I cannot tell you how many times some weird character breaks the character length function in Java and then kills the SPT tests whenever you test one of our parsing functions. It's beautiful. This thing catches that. Why? Because it'll generate, you know, about 10,000 test cases, and it generates all the dirty ones. So like throwing you null, or throwing you weird characters, or sending you a string that is really close to a maximum size, that kind of thing, and make sure that you can handle weird things, or weird tests, weird cases. These properties can compose. So here I'm saying generate me 2 strings. Well, I can actually create generators. I can say this is some sort of enumeration. I want to actually select one of these at random, and I can create a generator of my custom enumeration and eventually build up, here's the sample data I want to test, make sure all these properties are true no matter what input comes in. This is a really great way to make sure your business logic handles cool stuff. On top of Scala Check, there are 2 other frameworks which try to make testing more elegant. ScalaTest is one of them. ScalaTest uses a trait-based system where you say this extends a particular type of test I want to write with some extra helpers, and you keep adding these, and then you get a very human-readable test spec. Here's an example. Stack should pop values in first last order in, and then the code. All right? I would prefer to write this over JUnit any day. It has some rich features for doing table-based testing. Good thing to look at. Specs is a different test framework in the ecosystem. I'm showing this immutable specification here. The syntax highlighter broke on this code that I wrote, so I apologize that it doesn't have syntax highlighting. Anyway, the idea here is you have an immutable specification where these specs, these E1s and E2s, you can reuse in test cases, the same way you get reuse of anything that's immutable and combinable. So it's a different way of looking at writing an elegant, human-readable test, but it's actually using this string interpolator and these immutable test combinators. So different way of looking at the same thing. Another thing you'll probably have to learn at some point is SPT. The main reason it's important was it had the first incremental compiler for Scala, really the only incremental compiler for Scala. So that comes out of SPT. SPT specifically optimized for keeping Scala hot in process, so you have really rapid development cycles. That's the main reason it's important to the Scala ecosystem. The Scala compiler takes a good bit of memory, and this actually is slow to load in the beginning, but you can get efficiency by kind of keeping it around, keeping it hot in cache. So SPT does that by default. Java went the other way, and they optimize for having very, very little amount of bytecode, not doing as much, and then you have efficient compiling that way. So this is the way Scala goes, and that's kind of the reason why SPT matters. Let's talk a little bit now about up-and-coming libraries. Streaming reactive libraries, core libraries, Spark, Scala JS. So a big thing you might have heard about now is reactive streams. Why do reactive streams matter to you? Reactive streams are a lot like RX Java, but it has this nice feature of back pressure. Okay, so what you can do with reactive streams, which I'm going to show you right now, this is code that exists in my slide presentation framework, all right? You create an actor system. I create a source that's going to read a FFmpeg file, okay? And you give it like the URL, the system, whether or not to play audio. And then I give it a sink, which is the terminal. So I'm going to render this FFmpeg into the terminal. And then I have this thing called an askifier, which is a flow. All right, I'm going to stream to the terminal from the Rickroll video, and then we're going to materialize this guy. And if I press R, that's a little loud. Okay, anyway, what you'll notice is when I press end, there was a little split second when the video stopped. right? But if we can go back, can we turn that down just a little bit? All right. Well, if we go back, there's back pressure, right? Until one side starts asking for data, the other side doesn't go. So that video is just sitting in the queue waiting to churn, and there's kind of this automatic back pressure built in. It's a really wonderful thing. So now we're going to step into another streaming thing. Streams are super popular right now. So Scala Z Streams is kind of a different mechanism. It doesn't have that automatic back pressure built in. What Scala Z Streams does, which is interesting, is you try to attach finalizers to every part of the stream, and you try to make sure you have these rich combination operators, like I want to take all the lines of this text file, I want to filter them, I want to map them, I want to intersparse, which means when you find an N, you split it apart. I want to pipe this into text encoding, and then I want to send it to a file, right? These are the combination operations. These are the things I'm doing on the stream. What Scala Z tries to do is allow you to attach, like, after you open this stream, automatically close it when the stream is done. We don't know when it's done, but we're going to automatically close it. That's the area they're innovating. You might want to check the current pull request, because there's certain things you can't do with that right now, but that's kind of why Scala Z streams are cool. Akka Reactive Streams has that in the sense of you can attach these things to source and sink, but the general combination operators, you can't just open up resources willy-nilly in the middle, and those are kind of two different things. A few of the differences are if you're looking for this reactive, but I want to automatically clean up resources, Scala Z Streams. If you're looking for back pressure, this is way better. All right. Another thing from the Rickroll is reactive collections. So this is what we actually implemented the slide API in. Okay. So we have reactive streams for doing the video streaming. The slide API is in this thing called reactive collections. These are building blocks for FRP. What reactive collections are is you denote the world in 3 primitives. I'm going to ignore the third primitive because we don't really have enough time to talk about it. But the 3 primitives are, I have an event stream of events that come out. I have a signal, and a signal is something where when I'm responding to an event, I can see what the signal has. So like an electric signal, I can see if it's high or low at any point in time, but it's not like a pulse, which is an event. So what we have here, for our slide control, we grab all of the events coming out of the keyboard event channel, and we collect these space events, the left key, the right key, the up key, and the down key. When you see a space, turn that into the next slide command. See left key, turn into previous slide, okay? And this turns into slide control. Next we create a label, right? The label is, I want to take all the FRP events. I'm going to start the signal with the key press of 0, pretend like that was the first event, and then I'm going to toString all the events I get. And what this label actually is doing is it's rendered here. If I start typing on the keyboard and I don't press R, you will see the key presses show up automatically. As the event gets propagated, right, it's going to the event shows up in the key string, it's going to look for anyone listening to it, propagate these things out, and eventually you feed it back into your render loop. So there was a talk last year with this where they built an entire 3D game engine. I'm not cool enough to do that, so I did an ANSI terminal thing, but it's a very powerful library. It's in like a 0.7. Good stuff if you're doing UI work versus underlying stream work, right? So that's the reactive stuff. I think I have 10 minutes, good. Another important thing in the ecosystem right now is what I call CATs and other FP frameworks. What's happening in the community is people are reinventing Scala Z, but they're trying to do smaller chunks of libraries. Okay, so little tiny micro libraries that are useful, that have less contention for you to pull in your project because they do one thing and one thing well, as opposed to trying to cover everything. All right, so we're going to go through these really quick. Simulacrum, if you're interested in type classes, makes the syntax a lot easier. Machinist allows you to add implicit operators very quickly to type classes. Discipline helps you encode and test mathematical laws. This is important for that Spire project where you're trying to have mathematical computations and ensure they abide by the laws. Kind projector is a way to do type lambdas, which actually happens to be important when you're doing this level of programming. There's something called algebra, which is about sharing algebraic structures. It's kind of like Spire probably will make use of these. And then there's cats, which is all about category theory. So the applicative functors that I showed before will show up in cats. The difference between this and Scala Z is there's definitely a big focus on performance here and a focus on minimalism. So definitely pay attention to this space. These projects are in various states of release. I don't think I would say use these in production, but I would say pay attention to them. They're coming. Another thing to look at is actually this thing called Rapture. Has Rapture IO. It's kind of a new and a little bit better IO library for Scala. So with Rapture, you can say, here's a URI. Slurp this thing in. I don't know if you like the name slurp, it just feels weird. But slurp in the characters and give me an array of characters from this URI. And then parse those into JSON. There's lots of little combinators on files. If you ever wanted to do file manipulation, Rapture actually probably has a nice, elegant way to do it for you. And it has some interesting ideas in it that highly recommend you look into. Galactic's another one that came out of ScalaTest. ScalaTest was doing some interesting things to make Scala code look elegant, write tests. It turns out that there were times in ScalaTest where there were features that people wanted to use the feature in production code. So what they did was they forked off a utility library for you to use in production that only has production-oriented things instead of just test-oriented things. So you can use this in production. Here's a cool little example is when you're doing floating point arithmetic, you never ever say equals equals, 2.0 equals equals 2.0, because depending on the computation, you might get just slightly off and it's wrong. So there's a built-in tolerance API where you can say 2.0 plus or minus, here's my error value that's acceptable. Built in, your equality's finally nice, right? I totally wish I had this feature when I was doing more analytics. This is beautiful. Galactic also has a different way of handling errors called OR. There's just a lot of good stuff in there. It is kind of a collection of just anything that ScalaTest needed that is generally useful. So it has a bit of a, you can't name one thing that it's good at. Because there's a lot of different sparse things. Another library that's up and coming that we started using in SBT and is starting to get used more is Scala Pickling. So in Java, you use serialization to send things out. I think we all know there are limitations to how that works. Scala Pickling is an attempt to fix a lot of the problems but keep a lot of the convenience. So with Scala Pickling, you create a pickler which knows how to take a set of bytes and destructure it into raw primitives. So the primitives are either a map of string value pairs, right, a collection of things, or an actual primitive. And I think by default the primitives are like string, int, boolean, that sort of thing. It also comes with a macro where it can auto-generate a pickler for a case class from the existing primitives it already has. So if I say I want to pickle a person, it will automatically generate me a pickler for string, or for name and age, because those are both primitives and it knows how to do it. You can always create a pickler by hand. You can make use of other picklers so they compose. So it actually solves a lot of the problems from Java serialization where it's completely opaque. But there's, it still has some limitations, but it's actually kind of awesome. This is like the Scala way to do serialization now. It's starting to come. It's in its first stable release. So with that caveat, take a look at it. Yeah. Oh yeah, the other beautiful thing about pickling that I really like, it divorces the actual pickle format from the destructuring of your class. So it can efficiently pickle into binary format, or you can pickle into JSON out of the box. If you wanted to implement XML, you could do so, if you really wanted to. I think this guy does. Anyway, if you don't know, this is Eugene Yakoda, and he's the author of the Scala XB project, so XML. I did not mention that one, I'm sorry. All right, the last thing to really take a look at is Spark. Right, Spark is really taking the ecosystem. It's really big and it's really cool. And the idea is, we're doing these big distributed computations right now, right? What's the most elegant way to look at a big distributed computation? And when you try to do a big distributed computation, you need to fragment the data as much as possible and deal with things on a very small level on a particular machine. Well, we already have a way of doing this in Scala with like collections and for expressions, where you can take a collection and deal with each element individually. Or you can, piecemeal filter and that sort of thing. So what Spark does is it takes the best of like a collection API and lifts it into a distributed framework. So I can grab, here, this example just takes a text file and does a word count. What's beautiful is if that text file happened to be, say, all of my logs across my cluster, this would still work. It's the same code, well, except for where the source comes from. You can actually create clusters for these things and go run it on the cluster, run it locally. It does a really efficient job of caching. It's a very good thing to look at if you're doing analytics and big, medium data. Final thing, Scala JS. I said the final thing was Spark. I forgot. I need Scala JS here. This is up and coming. This is just an example of targeting the DOM in Scala with types. Where this goes, I'm not actually sure. Like we're watching adoption. Scala JS, what I'll say is, if we penetrate the JavaScript market with Scala JS, it will be a big success. If we don't penetrate the JavaScript developer, what's going to happen is when we need to write web, we're going to use Scala JS, and that's what will happen with it, right? So it really depends on whether or not the JavaScript ecosystem is looking for types, which I kind of feel it is, given things like TypeScript and PureScript coming out. All right, anyway, thank you for the talk. If you have questions, we'll take them in a second. Here are just a set of links, which I'll include later, of this presentation. So Represent is where I got the idea for giving a presentation in ANSI. Pegdown is a parser for Markdown, which we made use of. Reactive collections is the FRP side of the framework. Akka streams is how we did the camera, movie player, and this thing. No, it's not working. Yeah, there we go. The ASCII art tutorial, I don't know if you guys read through this. If you ever want to generate ASCII art, I learned how to do it in Japan. It was very exciting. They were rendering anime into ASCII every time you run a build just to make you happier. So I totally recommend that. Not whatever makes you happy, kittens, puppies, I don't know. But there's a tutorial for how to do it. All this code is open source on Suereth streamers if you want to look at how to do fun, dumb, ANSI things. And yeah, does anyone have any questions about ecosystem, questions they've had about libraries? I know that this was kind of a big fire hose. Yes? SORM. Okay. So the question is about Slick and whether it's not verbose and SORM. I know people who have used SORM. I looked at SORM. SORM is SORM can be more elegant. Yeah. The thing I like though, the new Slick 3.0. It's not actually out, but they actually redid some of the APIs to try to the same thing Scala Z streams was doing, where you try to denote like this thing is going to get automatically cleaned up and then compose operations. Slick 3.0 added, and that actually makes it something you really want to take a look at when that comes out. The way they do it is very nice. SORM, I think out of the box is elegant. The way they're looking at things is not as hand tuned. So if you like, the reason to look at Slick is because you can hand tune SQL, and you can go the magic route, or you can go the verbose route. The ability to do the verbose route, I think, is important. It's a little more verbose out of the box, that is true. So, yeah. Next question?
Josh, if you're building a pure REST API server, would you recommend Spray or Play for the server side?
So the question is, if you're building pure RESTful API server, would I recommend Spray or Play? I think the answer to that is your team already using actors in their day-to-day life and are thinking in actors, or are they just kind of, taking data from here and moving it to there? Play is better if your team isn't in the actor world, because you're at a higher level. Spray is good if you're down in the actors and you really want to get the fine-grained control. So, yes? Oh, the question is, when is Spray HTTP going to be available? I don't know. Maybe these guys in the back can comment. I don't actually know. When is Akka HTTP going to be available? When it's done? That's what I would say. All right. Any other questions? Yes? How do you do dependency injection in Scala? What I would recommend is pass things in constructors. Yeah, so definitely keep everything in the constructor, and then you can use a dependency injection framework if you want, and you have all the same flexibility. But don't do the thing of instantiating a class that's completely empty and then setting crap in it. Do not do that. That will cause you lots of pain. But you can still use all the same dependency injection things that you wanted if you inject in the constructor. There is a Scala API, it's called Subcut, like the Scala way of doing dependency injection. There's also a macro one. And then you can always use Juice or Spring. I think that most people are still using Juice, because if you're doing dependency injection, generally you're still talking to Java. And I think I'm out of time, but thanks guys.